one of our big like development paradigms at Connext is always like aggressively reduce complexity as much as possible. So, one day we just like kind of sat there and we were like, what if we just rebuilt this from scratch? And we thought of it like, if we were going to redesign like a cross-chain protocol from the scratch, what would it look like? And like we spent like maybe 2 days like just talking about it and designing it, and then like we kind of proposed it to like the team as like a possible thing, like what do you guys say about this? And like the team was super into it, so we just literally like threw out everything we had, like like months worth of code, thousands of lines of code. We were like, we're just gonna throw all this away, rebuild it from scratch, and make it better.
Hello and welcome to the Devs Do Something podcast. On this show, we're going to bring you technical discussions with some of the best engineering minds and engineering leaders in all of Web3. I'm your host, Sam Flamini. I work on developer experience at Superfluid, who also happens to be the producer of this podcast. You'll see me on this show with my co-host, Joshua Trujillo, deep dive with some of these engineering leaders into some of the most fascinating topics in all of Web3 development. On this episode, we have Rahul Sethuram, CTO and co-founder of Connext. Connext is building the first fully trust-minimized cross-chain communications protocol to make blockchains composable. Rahul has been in the space for the better part of 5 years. Before getting into crypto, he started his career as an electrical engineer at Tesla, before ultimately starting a fintech business and then diving into Web3 and iterating his way through the proverbial idea maze until he landed on the idea that became Connext with his co-founder. In this episode, you'll get a behind-the-scenes look on what it takes to build cross-chain infrastructure, and you'll learn a little bit more about Rahul's story and how he thinks about the space more broadly. In this conversation, we hit on a ton of fascinating technical topics. Everything from optimistic bridge design to Connext's engineering process for everything from design to security to testing. We also hear about how they manage multiple rewrites throughout the lifecycle of the protocol, some of Rahul's favorite non-EVM tech in the space, and we'll even walk through the full lifecycle of a complex cross-chain operation using Connext. So this episode was a very, very fun one for us to record. We think that if you are a Web3 engineer yourself, or you work with engineers, or maybe you're just curious about the cross-chain infrastructure space more broadly, if you're one of those people, we feel like you're going to get a lot out of this conversation. You'll see timestamps in our show notes. You're welcome to use those to navigate the episode or just listen to it all the way through. We hope you enjoy. All right, so we're here with Rahul from Connext. Rahul, thanks for joining us, man.
Awesome. Yeah, happy to be here. Thanks, guys, for having me.
Totally. So we are super excited to talk to you today for the inaugural episode of the Devs Do Something podcast. And yeah, I guess we can kick things off with just a little bit about your background, how you got in the space. And yeah, we'd love to hear your story a bit before we dive into technical topics.
Yeah, totally. So actually, I started my career as an electrical engineer. My first job out of college was Tesla. It was kind of like my dream job. It was always my dream to work on cars, electric cars. That was like back when Tesla was like the coolest new hot thing on the block. So, that was a fun experience right out of college. It was like a tough job, but it was really like a good learning experience. Long story short, throughout that process, got into stock trading because of like the Tesla stock and whatnot. So kind of like got deep into the fintech-ish space, stock trading, options, started to look at like programming platforms, etc. And then got like an idea for a company in the fintech space, which was kind of like stock trading related, social networky type thing. So that was kind of how I jumped into the entrepreneurship world. I'd already picked up software engineering by then, so I was a technical co-founder on a project. Long story short, that kind of ended in somewhat of an acqui-hire. So got into something new and was kind of at a point where I was between jobs looking for the next thing I was going to do. This was around 2017. So like right after kind of the DAO hack, Ethereum was kind of like a thing that was like starting to become a thing. Like Bitcoin was kind of going through like its first couple boom cycles. So I just was looking for the next thing to do. So I saw Ethereum. I started to look into it. I was like, this looks pretty cool. Let me approach this from the dev angle. So I looked at the API, started looking at it as a platform. Then I started applying for hackathons. I applied for this virtual hackathon, ended up winning a prize. And I was like, oh, this is super cool. Look at this cool stuff you could do. Then I started going to developer meetups in San Francisco, where I was based at the time. And that's how I ended up meeting a lot of people. I met Arjun, who is my co-founder at Connext, and basically, that's how we ended up here. We essentially kind of gelled and about something totally different than what we're into now. Of course, we started out building fiat on ramps for ICO tokens. It was something totally different. But our main thesis, and this is still our thesis with Connext today, is along the lines of how do we make Ethereum accessible? How do we make it make Ethereum serve the next generation of users, the next billion users, and how do we make it easy to use for your grandma? And of course that looks very different, and we got into very different things, but we've always kind of approached it with that, whether it means the developer interfaces or the actual user interfaces, or how we present things to normal people. It's always kind of been I want my grandma to be able to use this really cool technology.
I love it. I love it. So how did you guys end up on this problem of bridging and interoperability and Connext overall throughout this process? I know the idea maze looks different for everybody, but would love to understand what yours was like.
Yeah, totally. So, just to continue on from what I was talking about, so we were trying to build these fiat on-ramp type solutions. We had a bunch of partners that were interested in the idea. And this was back when the Ethereum blockchain was starting to have scaling issues. So, what we were hearing from our partners was that Ethereum is not able to scale as it is. So it's not going to support the level of mainstream users that you guys are trying to bring into the space. So, we took a step back from that, and we were like, okay, well, if the chain doesn't scale, then that's the problem we have to attack first. So then we got into scalability. This was 2018-ish, pre-roll-up, pre-anything. So the scaling solution at the time was state channels. So that's kind of how we started building for scaling. We started building state channel based solutions. We actually shipped the first payment channel hub on Ethereum that was in production. That was with SpankChain. We basically collaborated and incubated this idea with SpankChain. They built a live tipping thing for their cam feeds and stuff. So it was cool. It was a fun project, and we got things into production like that. But then, that was during this time, kind of roll up started to become a thing. And then that was looking clearly that was going to be the scaling solution. We were in state channels. We kind of almost bet on the wrong horse there, or kind of missed the sort of pivot over to roll-ups. But by that time, what we noticed is that there were multiple roll-ups, and there were all these teams building roll-ups together. And we were like, okay, well, there's going to be multiple roll-ups. So there needs to be some kind of interoperability between this. Then we realized, we made this realization that state channel hubs actually work as cross-chain bridges, because you can have this hub that settles, takes funds in one chain and then settles it on another chain. So we basically hacked together our system into a cross-chain bridge, and that's how we built the very first version of our Connext bridge, which was the vector-based state channel bridge.
I love it. Yeah, we'll get back into Vector in a little bit, and I want to hear how Vector evolved into what you guys have today. But I think we should touch on some of the thinking around bridges and some of the problems with them before we get into that, I think. So you guys have talked a lot about this concept of the interoperability trilemma. Do you want to explain for our viewers what that is?
Yeah, totally. So, what we've seen with the current amount of bridge designs is that there's always some trade-offs. What we've defined the interoperability trilemma is this trade-off between generalizability, which means the ability to go to different chains very easily and be kind of a platform that is available everywhere on every chain very easily. Trust minimization, which of course means you want to reduce the amount of actors that you have to trust in a bridging solution. So you don't want to have a multi-sig or any kind of custodial based solution that can rug your funds at any time. And extensibility. So for us, extensibility means the ability to kind of compose your bridging technology in with other sort of solutions. So make it like a DeFi building block, essentially. So that forms this interoperability trilemma, which you can see in some of our writing and stuff like that.
For sure. And my understanding, you can correct this if it's incorrect, but my understanding is that what you guys are doing with Connext is providing tooling to allow people to, I guess devs mainly, to navigate those trade-offs, right? I mean, it's going to be tough to solve everything at the same time, right? That's why it's a trilemma. But I think the idea is that you're allowing people to take different layers of the stack, compose them together to build their own solutions that make the most sense. Is that the right way to think about what you guys do?
Yeah, in a way. So, this was kind of like based on the current amount of solutions that were available that we built this trilemma. And then, we came upon this concept of like an optimistic bridge, which I think, maybe is one of the topics that you want to talk about later. But, long story short is this optimistic bridge more or less solves this trilemma by adding like a new dimension to it. So it becomes like a quadrilemma, which 3 of the 4 edges are basically solved by the optimistic bridge, but it adds another layer to the trilemma, which is latency. So now you have like a way to get everything solved. So you have your generalizability, your trust minimization, and your extensibility. But the trade-off is that you add a new layer, which is, your bridging is not instant, and you have some wait period that you have to wait for fraud proofs to be able to be pushed through. So then what Connext is doing is we are basically solving that quadrilemma by adding an extra layer of like fast liquidity on top of that. So you can use this optimistic bridge, which has like the very good security properties, but then you can also use Connext's like liquidity layer to instantly bypass that and use actors to like off-chain actors to essentially like pass funds and also data between different chains.
Yep. That makes a lot of sense. I mean, we can touch in on optimistic bridging now. I think it might be a good opportunity as well. We're recording this on August 3rd, so 2 days ago. Nomad had a bit of a hiccup, and they had an exploit. But I think it might be worth, Rahul, touching on the fact that had nothing to do with the optimistic bridge model. It didn't have anything to do with the economic security there. It was something separate. Do you want to just provide some clarity for people on that one?
Yeah, absolutely. And of course, like our hearts and thoughts and whatever and love goes out to all the people that were affected in the hack. Of course, we supported some of the chains that Nomad was using. So some of our liquidity providers and users were also caught holding these assets that did become unbacked. And it's very unfortunate this happened because, we and Nomad together have been like kind of really driving forward this vision about optimistic bridging and how it is really the only true trust minimized solution that solves this trilemma that we've put forward, right? So, essentially the optimistic bridge, the way it works in a nutshell is it uses this latency period to allow for one of n watcher actors to be able to prove fraud on the origin chain before messages are seen valid on a destination chain. So it's a pretty simple, in a nutshell, like, to explain like that. Like you just have something that happens on one chain and then you wait some time and then something happens on another chain. But the really important thing about it is it's one of n model rather than n of m. So when you have like a multi-sig or a validator based bridge, you're saying like n of m people are allowed to make this decision on whether or not like this bridge is valid. And, with that power comes the power to like mint tokens, essentially, in the case of a token bridge. So you're saying these m of n actors can mint these tokens anytime they decide to. And of course, like incentives might make it so that they don't do the wrong thing, but the idea is like they can at any time and you're trusting them. But with the one of n model, you say, okay, during this period, anybody can report fraud. And if that fraud is indeed proven to be a valid fraud case, then you can take the right countermeasures, which, in the case of a DApp would be like to pause other messages from going through while the fraudulent message is like unwound and replayed properly.
Makes sense. Yeah, I think that's great that we just laid that out specifically in detail, right? Because I do think it's very innovative. And I do think it is going to solve a lot of these problems in the bridging space for sure. While we're on the topic of the detail, like walking through how this works, I think it might be interesting for people to, because this is going to be mostly dev focused as a podcast. I think it'd be interesting to just walk through the life cycle of like a common Connext transaction. Would you be able to just walk us through like a standard, like let's say that I'll use a somewhat arbitrary use case, but let's say that I have a custom application that can send a single transaction on like L1 Ethereum to provide liquidity to Uniswap on Polygon or a separate chain. Can you walk us through like what that would look like?
Yeah, absolutely. So yeah, in your case that you're talking about, so a user is going to send funds on Ethereum L1, then the Connext routers, which is like a network of liquidity providers, then will all submit bids to actually be the one to execute the transaction on the destination chain, which in your example, I think was like Optimism or something, right? Okay, let's just go with that. So Ethereum to Optimism. So your then these liquidity providers are all going to have some time window. In our case, I think it's like 30 seconds. So they all send their bids to this actor, this off-chain actor called a sequencer. And the important thing to remember here is since this is off-chain, the router can actually, the liquidity provider, the router can make sure that this is a perfect message, that this is like constructed in a way that there is no fraud and this is going to be delivered on the other side. So this router has like this power to know that this message will be delivered at the end of this fraud period on this side, because it can see that there was no fraud, everything is working, everything is constructed properly. So because it like has this knowledge of both chains, it has data availability, it is able to instantly pass this liquidity across, and then it's able to use its own liquidity to basically give the user this set of money that it wants on the destination chain. And then also your example is really good because you're saying provide liquidity on Uniswap, which means you have to pass some call data as well. So on this side, this user will specify, okay, I want to call Uniswap contract on this destination side and call it with a little bit of call data, which will put the tokens that I send with the bridging into this contract with some extra call data. And it's very important to note here that there's different types of call data as well. You can have unauthenticated call data and authenticated call data. So what this means is, okay, this is gonna I hope I can explain this properly because this is a pretty important concept. So the Uniswap contract on the destination chain does not have the enforcement that it must be called by a message.sender. As a liquidity provider, you can say, I want to provide liquidity on behalf of address C or whatever. So whoever is providing liquidity does not have to be the person that signs and sends the transaction. And this is very important because you're saying this set of decentralized actors who are the liquidity providers, any of them at any time can send this transaction for me. And since I don't know who that's going to be, I can't beforehand restrict that on the destination side. So this is unauthenticated data. And this means it can be instantly bridged and that there doesn't need to be trusted because, what you're saying is anybody can call this contract function at any time. The other case is authenticated data. So in this case, it was all good. We could do this right away. But, there's another case of applications where you say on the destination side, I want to be very sure that this data comes from a specific user. So either you can do this a couple of ways. You could say, okay, I want their signature. So if it's their signature, then this is also still unauthenticated data because you can just check the signature. And if you're checking the signature, it belongs to an ELA. But, if you're saying okay, I want a DAO to execute some action on a destination chain for a receiving chain, you want to be very sure on the destination chain that this came from the DAO contract on the origin chain. So with that, then you need to say, okay, I only want to trust messages coming from the bridge. So that means I only want to trust messages that have gone through this fraud period because I want to make sure that these are the messages that are actually valid. So because of that, you have this combination of things that you can do. You can do just tokens, which are instant. You can do tokens plus unauthenticated call data, which is also instant. And you could do authenticated call data. And this all lives in this interface, which is the Connext XCall interface. And, to go back to your point about the life cycle, So let's just keep using your example. So we're at the point where the router provided the liquidity to Uniswap on behalf of you. So now you have tokens sitting on Uniswap. And, by the way, like, of course, we have made it so that the router cannot change, for example, and say, like, I'm going to provide liquidity on behalf of myself, because then that would mean the router does not get paid back in the end. Like, so all the call data gets like hashed into like one thing, which is a transfer ID, which makes it so the router can get paid back at the end. So now router has paid back. So now it's like sitting, it's has less liquidity than what it started with. And then at the end of the fraud period, now the contract will see when it recovers the funds at the end. So like basically at the end of the fraud period, now new funds are minted through the Nomad contracts, the optimistic bridge contracts. So they will go ahead and mint new funds, and then they will see that the router fronted this transaction. So then they will send the funds to the router instead of to the user who initially sent the bridge transaction. So that ends sort of the whole life cycle.
I love it. That's a fantastic explanation. And I wasn't even aware myself of some of the conditional logic you could add in. But that's really, really powerful. Josh, so this is actually an interesting lead in. So Josh actually has been working on a spec to do cross-chain money streaming with Superfluid using your contracts. And he's been raving about the developer experience, right? Because this is not simple, right? That's not like transfer funds level stuff, right? This is complicated. Josh, what was that experience like of sleuthing through those contracts and figuring that out?
Yeah. So, overall, I mean, like Sam mentioned, bridges can be really, really complex, and they can be, pretty difficult to build contracts for and things like this. So, for one, obviously the documentation was great. Really explained a lot of these inner workings. But I've also noticed, and something that I really want to shout out to, because personally, I love keeping up with these latest versions of Solidity and smart contract development in general. And I've noticed a lot of these really modern patterns, that Connext uses that you don't really see in a lot of code bases, right? Because Solidity, iterates so rapidly. There's so many new features coming out. It's hard to keep up, right? A few years ago, you couldn't pass functions to functions. You didn't have custom errors or any of these kinds of things. So having direct access to these kinds of things, within the Connext code base was, pretty great. And then also it is, fairly straightforward, right? Working with this, building the cross-chain call data and figuring out, I mean, there's a lot of configurability here, right? Like I've noticed there's, of course, you can send the funds, you can specify what token to send, you can specify, like you mentioned, call data. There's a callback option, there's all kinds of things, it's really, really cool. It's very configurable. One thing I would like to ask though on that, because I noticed there is like this callback field. So what does that callback look like? So let's say we go from Ethereum to Optimism, keeping in theme here. So you send this message across, and what this message does is it can optionally send tokens and call data, and this happens on Optimism. So where is that callback called? Is that on the origin chain, destination chain? Like how does that callback work, and what's its use case?
Yeah, that's actually a great question and a great thing to get into here, because once you're dealing with like different chains, you lose the synchronicity and the atomicity of the blockchain itself. So like, a lot of stuff is done on blockchains because transactions are fully atomic, and you can do a lot of cool things. You can do like flash loans and things like that, which would not be possible if you don't have atomicity. But kind of like what we've seen is that like the way the world works and the way things on the internet work is they are all asynchronous. So like when you do things on the internet, you like send a request and then you wait for a response. And like JavaScript has like a really cool, like, promise dot await, whatever, like dot then, like, you can do all these different ways to set up callbacks in JavaScript. And that pattern is not present in Solidity, obviously, because it doesn't need to be. But, once you deal with like cross-chain stuff, then you get back to the point where you want to do things like, you want to have the ability to do things asynchronously. So that's exactly where this callback comes in. So like your example, like on the origin chain, you want to send some message, you want to like grab some data. Let's say you want to like read the like block height or like something, or like read some like price. Okay, let's say you want to read like a TWAP price. This is a good example. So you have like a TWAP running on this chain. You don't have this TWAP feed on this chain, but you want to see what the price of like some sort of token is. So you'll send a call you will specify that you want the callback to be like this contract here, which implements a simple callback interface. Then you will hit this contract on the destination side. And then once it gets the data, it will basically send another bridge transaction back the other way. And then it will call your function, your contract, calling the special function called callback with this data that it gets from this. So, you would set up your contract so that it knows how to decode the data you get back and everything like that. And then you would have essentially a way to get a callback. And yeah, it's kind of like a new pattern that hasn't really been done. And we think that this asynchronous solidity is kind of like a thing that is going to exist. And we really want to like support this from the get-go.
That's really cool.
That's fascinating. Because this is a hurdle that, we came across when we were building this cross-chain streaming prototype where, everything in Superfluid is dependent on the timestamp, right? You can't compute a real-time balance without some sort of, time there. And it turns out time is a really, really hard problem, right? Especially between blockchains, you have, there's no guarantee that, these block times are exactly the same. Different blockchains actually have different, thresholds for, where that timestamp needs to be. And being able to send that timestamp back across the bridge would be really cool. One more brief question is on that actually. So if you use the permission call where it goes through, the Nomad bridge, it takes the long way around. Does that, when the callback happens, does it also go back across the Nomad bridge again?
Yeah, so that's a good question, a good point, because the callback by necessity has to be like authenticated data, so it has to go through like flow path. So when you're dealing with things like time and stuff like that, you have to kind of like build in the fact that it is going to be like delayed by some amount. So especially this is important for the example I gave, like TWAPs. Like there are projects we're working with that are already working on cross-chain TWAPs, and like this had to be a consideration for them, like what the time period is. But yeah, the point is that it does have to be like authenticated data. Otherwise, anybody would be able to like call this callback function, like kind of trick you into thinking that. So you have to kind of validate that it comes from the bridge itself.
I love it. So Josh mentioned he liked some of the modern patterns you guys are using in Solidity. Something that I think we'll try to ask pretty often on this show is, are there any gas optimizations, storage optimizations, or patterns that you're just really proud of in the Connext contracts that might not get a whole lot of public love that you'd like to share?
Yeah, that's a good question. I think like Joshua said, it's like we do try to use the most modern stuff and keep up with the stuff, especially like, even as we're building out these contracts, we're like basically always upgrading to the latest version until we have to like freeze for an audit or whatever. So we're always kind of like pulling it in. And one thing that like came up as we were building that was this whole like new like error pattern where you use like an error class instead of like a revert. Instead of normal like revert string, you would throw like this error class. So that was something that we like put in immediately right away. That was that was super cool. As far as like other things go, I can't really say there's anything too crazy there. Like we really try to go for like simplicity and readability, even at the cost of like certain things like gas savings. So like we've always kind of like erred on the side of like making things as readable and simple as possible. Like I think even, like going back to this Nomad exploit, it's like you really see like how little bits of complexity can like add up and cause you to kind of forget things or kind of like miss things. And like, even like really important things that you think are like, you'll never forget about that. It's like, there's so much going on in this stuff and so much complexity that kind of builds on top of each other that you just need to reduce complexity as much as possible. So I'd say like the thing I'm most proud about is like how simple we've kept everything and how much we focused on like the outside facing interfaces as much as possible. Like, just to kind of like highlight on this XCall thing itself, like we tried to make this like as kind of like analogous to the normal Solidity call pattern. Like we were like, this is just call, but XCall, like, and eventually we want to get this in things like Open Zeppelin and like have it really be like a primitive that can be used the second you want to start doing cross-chain stuff.
No, I'm with you. Yeah, readability is really important, right? And I noticed that when I was looking through your code base at Xcall, right? It was pretty intuitive. So yeah, no, I love it. So zooming back out again to just your high level development process, right? You mentioned earlier that initially you guys started with state channels and something called vector, right? And now you
Mhm.
have a new system that's more generalizable. I'd love to understand what that development cycle looked like over the last year and a half or so. Can you shed some light on how that all worked?
Yeah, totally. So, yeah, like I said, Vector was state channel based bridge. It's cool. It's like trust minimized. Like every bridge solution we've built has been like trust minimized because that is just like the one thing that we've always kind of prioritized as our number one priority is to like not introduce any kind of trust on top of what the chain's already introduced. So you don't have to trust some centralized actor. You don't have to trust some like M-event multi-sig. We have routers who are liquidity providers. The only thing they could do is like kind of censor transactions in a way, like they can kind of like pretend they're going to send you liquidity and then they're not, but like at some point it's going to expire and you get your funds back. So, things like that. So like the consequences of some of these actors in the middle is not much for what they can do compared to like a full on run. But anyway, so like, yeah, Vector, state channel bridges like do have some trade-offs themselves. Like first of all, there is a lot of complexity in the off-chain code itself. So like not much of the code is actually on-chain in the state channel implementation. A lot of it is off-chain. So like you have these two off-chain actors that are like basically sending messages back and forth with each other to do this whole transaction. It was like crazy. It was like 10 messages going back and forth over the wire to like do like a cross-chain bridge transaction. And like this is all running like within the browser. So it's pretty cool architecture. We like ran like a node inside the browser that like had its own like wallet address that was deterministically generated based on your signature. But that meant you don't have like cross device support. And that meant like, if you like refresh at the wrong time, we have to like resync you. And like that can like cause things to get like weird at some point. So there was a lot of complexity we were dealing with there. And like, like I alluded to before, our like one of our big like development paradigms at Connext is always like aggressively reduce complexity as much as possible. So, one day we just like kind of sat there and we were like, what if we just rebuilt this from scratch? And we thought of it like if we were going to redesign like a cross-chain protocol from the scratch, what would it look like? And like we spent like maybe 2 days like just talking about it and designing it. And then like we kind of proposed it to like the team as like a possible thing. Like, what do you guys say about this? And like the team was super into it. So we just literally like threw out everything we had, like, like months worth of code, thousands of lines of code. We were like, we're just going to throw all this away, rebuild it from scratch and make it better. So that's how we got to NXTP, which was like the next iteration of that. And then NXTP is great. It's, in the trilemma, it kind of sits between like, extensible and trust minimized, or sorry, generalizable and trust minimized. But it's not very extensible because you can't do these cool like smart contract based interactions. You can't do like, what you guys are building, like cross-chain streaming through like NXTP. We've actually been talking to you guys for so long to figure out how we could do that through our protocol. And that wasn't even possible until we came up with this new protocol. But so those are some of the trade-offs we wanted to address with the new system. So that's why we kind of went back to the drawing board again. And then we're like, okay, well, what would this look like if we were going to rebuild it from scratch? Then, exploring from what was there already, we saw like this optimistic bridge design that like, the Nomad team had kind of just started working on. And that's when we kind of like went to them early and we were like, okay, like instead of building our own thing from scratch, let's partner and build this in layers. And that's kind of how we got to where we are now. So I guess one thing is like, we've never really been afraid to like throw everything out and start from scratch, like for better or for worse. Sometimes that makes it worse because then like, you kind of like have to like take some time where you're either supporting two different systems or you have like a lot of downtime in between. But, I think our approach has always been like, let's get rid of complexity. Let's like redo it in the most simple way possible instead of like adding a bunch of stuff on top to make it do something.
I love it. Yeah, that might be a good segue into how you guys operate like from a more meta level within your engineering team. So it sounds like you've literally gone back to the drawing board and said, all right, let's start from scratch. Let's rebuild a lot of code. Let's think about this from first principles again. How do you guys tend to approach these new development cycles? Do you just literally like get together in an offsite and say, all right, let's figure out how we can do this first principles again? Do you guys do like OKRs and stuff, sprints? I mean, how does your development cycle tend to look?
Yeah. So we are a fully distributed team. We have team members all across the world. So like asynchronous communication is always like a thing that we have to do. But like, like you just alluded to, like offsites are a really good opportunity to kind of come up with these things and design these things. So we have like, timed offsites specifically around these kinds of upgrades, like, to kind of coordinate the Amarok upgrade. We did like a big team offsite, and that does tend to really help like kind of get everyone on the same page. And then, kind of when everyone has that idea, then we do have like sprint planning, sprints, and we do go through the normal sprint cycle. I mean, one thing I'll say is like we used to manage the sprints kind of like as the engineering team and have the engineers manage the sprints. And like I was kind of like doing a lot of like the sprint planning and stuff. And finally we hired like a program manager, project manager. And that has been like a godsend in terms of like just getting rid of like moving the stuff off the engineer's plates itself around like task management and sprint planning and kind of like that more into like a just, now here's what we have to do. We know how everything's structured. We just go and build it.
Yep. Yeah, we've taken a similar pathway in certain areas. It's super fluid. It's definitely helped. We're with you 100% there. What about just overall like maintenance and security? How do you guys think about that? Do you guys have any like processes you think that the rest of the ecosystem should probably know about and potentially implement? Do you have any crazy GitHub actions that you're proud of? How do you guys think about that whole process?
Yeah. I mean, that's definitely becoming more and more relevant thing today in terms of like, all these hacks and exploits, and especially things like the Nomad thing, which is like upgradability, configurability kind of issue. So I think it's really important, and that's something we're going to really like deep dive into going into this upgrade. It's like how to really structure the stuff around it. Like, traditionally we do have our normal set of like GitHub actions. We have like our staging environment set up. We have like a, set of tests that runs on staging before it gets promoted to prod. We have a normal set of like unit tests. We require like everything to be fully unit tested. We've actually kind of built out a very cool like unit testing framework for things that does like, very cool levels of mocking and things like that for the off-chain code. All the on-chain code is tested using like Forge, Foundry tests. We are in the process of implementing like fuzz testing on everything as well in Forge and Foundry, which is really cool. Then we have like fully local end-to-end tests, which basically spin up all our off-chain agents, spin up multiple chains, and then like run a whole suite of tests, fully local and reproducible. That was like a pretty hard thing to get set up, but I think it's super important to do. But really we want to like, super deep dive into this exact topic over the coming like days, weeks, to really figure out like best practices approach towards like how do we make sure code is production ready, like what are all the real checks we need, and then in terms of like things like incident response, how do we make sure like what's the worst case scenario thing that can happen, like a huge smart contract bug, like how are we going to respond to that immediately, even to things like where can we like put kind of like real checks in place to make sure like certain things don't happen, like can we like do we need to make things like pausable in certain places and have like automated actors that are watching and checking? Can like one really cool thing about this whole like optimistic bridge technology is actually in this fraud proof window, you have like a 30-minute window to basically like check a lot of different things. Like, yeah, you need to check like the fraud on the basic like Merkle proof level, but you can also do things like has like the chain been exploited? Like, do I need to like shut this down because there was some like external issue external to our entire system? Excuse me. So because of that, like because you have this window, you can like add extra levels of monitoring, observability, and like response to it as well.
Yeah, no, that's really cool. And I think that sometimes that small window or even having some kind of circuit breaker is actually there's arguments as to why. Like I know Josh is big on smart contracts. You deploy them once, they're immutable. He's big on, he likes immutability, but the ability to have that kind of window is helpful, right? So
yeah, I mean, sorry to interrupt, but I think we went through that exact thing. Like all our contracts we deployed, like from the early days, were fully immutable, no ownership, nothing like that. But now we're moving to an upgradable, pausable pattern because, when you're dealing with this, especially when you're dealing with like bridges and cross-chain stuff, there are like all these kind of externalities and all these sort of like unknowns and risks that like you take on as a bridge and, your liquidity providers take on that like really you do need some level of control more than like normal DeFi apps or like single chain apps or like things like that. Like there's just a lot of unknowns, especially right now. I think things are like still being figured out in this space where there do need to be like some level of like, of control over this stuff. We've yet to see like what that will fully look like, but I think we will do as much as we can towards this.
Yeah, I'm with you. You guys definitely have a lot of surface area with the different environments and things. That makes a lot of sense. So you guys are all EVM now, right? You support EVM environments only?
Yes, we do support EVM environments only. That is not like the long-term plan, but that is probably like the short, medium-term plan. Just because, it would take a lot of effort to rewrite all our smart contract layer in any other language. And what we're seeing now is like we're seeing this bridgehead thing, right? So like any non-EVM environment is basically getting like an EVM based like roll up or like a layer on top of it. So like you see that with like, with Near and Aurora, with like Neon on Solana and Moonbeam on Polkadot, Evmos on Cosmos. Mm-hmm. So all these environments have basically like an entry point through EVM.
Mm-hmm. Have you thought at all about what it would look like long term to rewrite those contracts? Because we think about the same thing sometimes, right? We're EVM only as well. Like we want to be, again, long term future, it'd be great to be agnostic. But I mean, have you guys thought about what that might look like when it happens?
Yeah. So we actually have kind of designed things with the ability to eventually be like non-EVM compatible. Like we wrote our RPC layer in a way that like the RPC interface itself is like a plugin. So you could just write like a plugin for a non-EVM layer. We use subgraphs as well. So subgraphs are already like expanding past EVM into like other non-EVM layers. I think they have Near or something like that. They have already announced something like that. So that's kind of like another layer of abstraction on the chain itself. So we do try to like put in these layers of abstraction as much as we can so that it's as easy as possible, like plug and play the EVM itself.
And if maybe we could get a little philosophical for a moment, just big picture here, right? I mean, the EVM is a relatively simple machine overall, right? Only a handful of instructions. It's a stack machine, pretty easy to reason about. Yet it's wildly popular, and maybe some of that is having that first mover's advantage. But it's so popular that you have zero knowledge scaling solutions that are arguing about who's actually EVM equivalent, right? So what are your thoughts about the EVM when compared to other blockchain virtual machines?
Yeah, I mean, I haven't dove too much into the non-EVM space, honestly. That's always been something I've wanted to do, but I just haven't really had the time. But from what I've heard, like the Cosmos ecosystem has like really good like SDKs, like the Cosmos SDK. I constantly hear about that. And actually I talked about our like centralized component, which is a sequencer right now. Eventually, our goal is to have like some sort of Tendermint consensus between all our liquidity providers, so that would like decentralize the whole protocol itself. So that would use the Cosmos SDK, which is kind of like a building block for the entire Cosmos ecosystem, which does seem to have like really cool like inter-blockchain communication (IBC). That is really cool, and like I've always wanted to kind of explore that more. I also think Rust smart contracts could be pretty cool, but I haven't really seen what they look like in practice. Another thing that I'm seeing recently is like this move thing. Like, I don't know how much you guys have seen of that, but like there's like this whole like thing with this new language move. And like, it's like, I've actually seen very positive reactions on like Twitter from like some of the the developer folks that I follow and saying that it works really well, and that they've even like introduced some like tooling and stuff around it. So I'm kind of excited to see like how this plays out.
Yeah, for sure. And I mean, the move language, from what I've seen, I mean, very, very brief experience with it, but it is very Rust-like in syntax. A lot of people tend to call it like a more simplified version of Rust, which, by the way, I heard that earlier. You said dot await. That's a Rust pattern. Somebody's been playing with Rust. I love it.
It's, yeah. Oh, JavaScript has the await too. Yeah, but I know Rust is awesome. I really, my goal is to like rewrite all our stuff in Rust. Right now it's just like all like Node.js TypeScript stuff, but eventually we want to get to the point where we can do more Rust stuff.
Awesome.
Cool. So a couple other questions before we wrap up, but one thing I think we should hit on. So there's a bunch of noise about zero knowledge stuff, right? And I saw you guys recently put out a piece on validity proofs and bridging. Can you just kind of give us an overview of like where validity proofs might fall short when it comes to being used within bridge technology, and maybe where they might be promising? I mean, I would love just your overall take on that.
Yeah, totally. Yeah. So, because fraud proofs have been like a kind of an evolution in bridging technology, people are kind of like wrongfully assuming that because fraud proofs are a thing, like validity proofs might also be a thing. And then like everyone is kind of like hand waving around like ZK stuff as like being like the be all end all. But in reality, like what this article puts out, like, what I would urge everyone to read as well, because, I'm not the expert in this field, but like our researcher Hadas did a lot of like deep dive into this, is that like validity proofs are actually like not going to be the answer, and ZK proofs are not the answer, because what you really need to do is you need to like validate the consensus mechanism from one chain and another chain. And like one part of that is really easy. But the other part of that, which is like the actual like consensus and the availability of the nodes itself, is like impossible actually to do in a fraud proof, or in a validity proof, and especially using ZK stuff. So with that said, it's essentially impossible to have a fully validity proof based like cross-chain system, because that's just not going to work. You're not going to get all kinds of chains. You're not going to get all the chains to do it. There are some approaches where you could get like light client information from one chain to another chain. Actually, one place where this is most likely going to happen is like within the Ethereum and rollup ecosystem. So I think, eventually once we have like full ZK rollups, we will have like the data availability, cross-chain data availability. So I think we're going to see that space evolve into something like really cool, where you can have like, you basically won't need bridges anymore when you're going between different ZK rollups and Ethereum. You will just basically be able to have like fully like cross chain communication, like directly natively built into like nodes and stuff like that.
Nice. Does some of the, and forgive me if I'm misunderstanding some of this, but does some of the issue with the validity proofs come down to reorgs, or is that a separate issue?
Yeah, that I think, or I believe that's a separate issue. Again, I wish I was more like the expert on this matter, but I believe that's not really the issue. The issue is more around like availability and like the consensus of the nodes itself, like proving that all the nodes actually saw the transaction. You actually did have like M of N, or like whatever, 51% consensus around the thing. And each chain has its own different like consensus mechanism. So just because you build these validity proofs for one chain and it works somehow, even if you like solve all these like unsolvable problems on one chain, then you have to go solve them on another chain. So it doesn't really scale to like a kind of mesh solution like the one that we're looking for.
Makes sense. Yeah, thanks for clarifying that. But yeah, I'll put the link to that article in the show notes, because I think it is a good read for people that are curious. Okay, so couple final questions for you. These are a little more high level, but let's say that let's say somebody gives you the next 6 months and says, Rahul, you can't work on Connext. You got to work on something as an independent developer in this whole like cross-chain ecosystem space, or the ecosystem more broadly. What kind of things would you look at working on? What other things do you get excited about?
Yeah, I mean, I actually do get really excited about like DeFi. I love like DeFi primitives, especially. So things like lending protocols, like swapping mechanisms, like things like that. So I'm definitely interested in that. I've always kind of like wanted to like build some kind of like cross-chain native like application that's kind of like on the application side. So I would definitely go somewhere in that direction. I've also, I would love to like learn more about the ZK side as well, especially, the stuff that you guys have brought up as well. So like, I don't know much about like how the proofs work, what these proofs have in them, like how to construct them. Like, I feel like very much like a newbie still in terms of that. So just kind of getting into that. And the other thing I'm super interested in is like MEV stuff. Like, I think that's been like a big hot topic lately. So, not like, more like on the block building side, like the actual like searching for opportunities, like, things like front runners, arbitrage, things like that are like interesting to me. I know some of that is kind of like like dark patterns, I guess, but like, just it's super cool to like see this whole thing play out and like all these different like forces you get in this like truly permissionless system.
Well, if I could maybe expand on that last bit a little, because I've been briefly studying MEV and kind of that process of searching and finding these opportunities, right? And people think MEV a lot of times they think arbitrage or liquidations or things like this, right? And so I was wondering, since there are incentives in play, right, with systems like Connext, are there any kind of sort of opportunities for searchers in there, or how does that work?
Yeah, that's an interesting question, one we've been thinking a lot about, because like we have been kind of approached around the idea of like using cross-chain bridging to arbitrage to do cross-chain arbitrage. What we've seen is that like when we delve kind of deeper into this, we've seen like it's not really possible because there are always actors with like funds on like both sides who are able to like instantly close arb opportunities like faster than you can like bridge and do it. So it doesn't really make sense in that case. However, we do kind of have the property of like our sequencer almost like having access to MEV itself. Like if you have like a bundle of like cross-chain transactions, you could essentially like order them, So there is some aspect of like our router sequencers having some sort of like MEV type information and basically like a mempool themselves. Like, we kind of like talked about it. Like we use subgraphs, right? So we have subgraphs on on the origin side and the destination side. Those subgraphs almost become like a mempool of sorts because you can kind of see what the transactions that are going to be bridged are. And like, you could use that to sort of construct MEV opportunities yourself.
Now that's some alpha. That's really cool.
That's right.
I love it. All right, so final question before we wrap up. This is more on just your long-term vision for our industry. Let's say that we fast forward 10 years, 2032. What do you hope exists in crypto and Web3 more broadly? What do you hope is the long-term vision of the space if we zoom out and don't look at all the craziness that happens on the day-to-day? Where do you think we end up?
Yeah, that's a good one. I like that. I think one thing is like Connext. We definitely want Connext to be around, and like that's really one of the things that we talk about a lot at Connext is we say we want Connext to be the only protocol, or not the only protocol, but a protocol that will be around in like 50 years. That's why we don't like compromise on things. We don't like really like take the easy way out, even if like, taking the easy way out would be like building a multi-sig bridge. Like some of our competitors have done that. They've like scaled way bigger than us and been able to scale quickly because of that. But, we don't want to compromise on that because we know like that's not the way towards like a sustainable protocol that is going to be around for the long term. So that's one thing. Of course, like on the other side, I think Ethereum, like I'm very bullish on like the Ethereum roadmap with the whole like merge, surge, verge, purge, whatever, like, all the stuff that Vitalik threw out for the different phases. So I'd love to kind of like see that come to fruition and really see like Ethereum become sort of this like real like global public infrastructure that's kind of used as the backbone for like everything, like finance, identity, like every kind of like public information that needs to be there can be there. with like fully customizable privacy controls because of zero knowledge stuff. So seeing all that kind of like come together as like this sort of end vision for like the stuff that we're building, and like obviously like streaming super fluid streams everywhere, like everybody should be using that for like any sort of like subscription, salary, like anything, or any other like cool things that you guys have in the works. So yeah, just like very bullish on the next 10 years in general. I think we're going to see like everything explode because of just like, all the stuff that's just being like built right now. And I think, it's hard because people outside don't really see it. They just see like prices and numbers and things like that. But like, we're on the inside, we're the ones who are like in the front lines, like building the stuff. So we get to see like all this kind of like inertia that's being like, or this like potential energy that's kind of like being created here. And it's just going to like explode into like all this like Cambrian explosion of stuff.
I love it. It's a great answer. Well, thank you for coming on, man. This has been a lot of fun.
Yeah, totally. This has been great. Thanks a lot, guys. This is really cool.
Yeah. And then just, where can people find your work? Where can people find Connext? I mean, where should they go to learn more about what you're working on?
Yeah, definitely. So Connext, big on Twitter. I myself am on Twitter at RHLSTHRM. Connext, we have a really popular Discord as well. So Twitter, Discord, usual suspects. If you want to get more involved, check us out on GitHub as well. We're always looking for contributors and stuff like that. Also, if you want to build stuff on us, like, we really want to find builders who are excited about building like the next generation of like cross-chain applications. So please get in touch with us about that as well. Really happy to help support.
I love it. Well, again, thanks again. This has been awesome. This has been a great first episode. You were a fantastic guest. And
thank you so much. Yeah, excited.
Absolutely.
All right, guys. Bye-bye. Take care.